All right, this is on properties of quadratic functions in standard form. So we've spent some time with the transformations of up and down, left and right, reflecting it about the x-axis, and then vertical stretches and compressions. The next thing is knowing when we have it in standard form, there is a axis of symmetry that runs through the vertex. So here is a chart that shows you where that line of symmetry is that runs through the vertex. So this HK is our vertex point. And that vertex point could be the maximum or the minimum of the parabola, depending if it's reflected or not. So example 1 says, identify the axis of symmetry for the graph. So there are 3 examples here, so 3 different functions. And what we want to do is identify the h. So the h is going to be inside the function. So here's our h, here's our h, here's our h. If you remember from a previous video, what that does is it moves the graph left or right. So this plus 5 is moving it left 5 units. So then the axis of symmetry is going to move left 5 units. So that axis of symmetry is going to be at x equals -5. The -2, we always say think opposite. This is going to move it right 2 units. So then the axis of symmetry is going to move right to x equals 2. Plus 1. This is going to move it to the left 1 unit. So then the axis of symmetry is going to be at x equals -1. Standard form. This slide shows you what standard form looks like and how it's manipulated from vertex form to standard form. I just want you to highlight this is standard form. And then this is vertex form. I'm going to have you fill in some blanks here. So standard form of a quadratic function, when this b equals 0, it simplifies it to y equals ax squared plus c. So where the line of symmetry will be is going to be moving to still at x equals 0. So still at the origin, or we call the y-axis. And then the vertex will be at 0, c. The y-intercept will be in that same spot at 0, c. If we have the c removed now, then the vertex will just be at the origin because my c is 0. When we have the axis of symmetry and we want to find it and the b is not 0, we're going to follow these steps here. So you can go ahead and pause if you want to, and then we're going to do some examples. So here's an example where we're going to give you a function in standard form. So we first want to identify the a. So the a value is 2. The b value is -4. And then the c is 5. And we want to identify, is this graph going to open up or down? So this is called concave. if the A is a positive number, here's our A right here. If our A is a positive number, it's going to open up, so it's going to look something like this. If our A is a negative number, it's going to look like this, open down, because that's where that reflection is. All right, so this is a positive A. So it's going to open up. Now, there is a multiplier. It's going to look wider, narrower, or the same as its parent. Since that's a multiplier of 2, it's going to look narrower. It's going to be taller, skinnier, because our A number is greater than 1, and our A is positive. So what's going to happen is we're going to have a minimum point somewhere down here. That's going to be a minimum point. Now let's go ahead and do our steps. So we want to identify the axis of symmetry. So there's an equation. We do need you to memorize it. X equals negative b over 2a. So we're going to substitute our b and a from up above, right here, into this equation. So x equals negative, and now we're going to substitute our b in, which is a negative 4, all over 2 times a, which is 2. And then we simplify it. So we get negative, negative, turns that to a positive 4 over 4, which is 1. So our axis of symmetry needs to be written as an equation, x equals 1. So then let's go ahead and graph that. So we go over on the x-axis to 1, and we create a dotted or dashed line. So that's our line of symmetry. The next thing is to find the vertex, which is going to be the minimum. So the vertex x is always on the line of symmetry, and we need to find the y-coordinate. So what we do is we evaluate the function for f of 1. So f of 1, we're inputting 1 into the function because we know our x-coordinate is on the line of symmetry. So we sub it in. So 2, replace that x with 1, replace the x with 1, and then simplify it. And we would do our orders of operation. So 1 times 1 is 1. Then we'll do our multiplication next. We get 2 minus 4 plus 5, and then add and subtract left to right, and we get 3. So the vertex point has to be written as an ordered pair. So it's 1, 3. So we go out and graph that. So here is our vertex point, over 1, up 3. That'll be our minimum point on the graph. Then we need to find the y-intercept. So to find the y-intercept, we evaluate the function for 0. So we substitute 0 into the function. And what happens is this first term becomes 0, the next term becomes 0, and then we're just left with 5. So again, just like the vertex, we want to identify the ordered pair as 0, 5. Now let's go ahead and graph that. So there's our next point. What's nice about that purple line is we can reflect that blue point across the purple line. So now we have another point directly across from the purple line, which is our line of symmetry. So now I'm going to start to connect my red point to my 2 blue points. So my reflection point is reflected across the purple line at 2, 5. Now we have 3 points. That is fine to create our parabola. I'm going to show you how to find a couple additional points. So I'm just going to sketch that for now. If we want to find additional points, we would just evaluate the function. So let's say we want to say f of -1. So we would substitute that into the function. And then we simplify it. I'll let you pause and do that, or type it in your calculator. And we get the order pair -1, 11. So then we would go up and graph that point. Right up about in there. And then what's nice is the reflection point is going to be the same distance of 3, 11. If I want to evaluate it, f of 3 and then simplify it, you can use your calculator, you're going to also get 11. So that order pair then is 3, 11. So the purple line is your axis of symmetry. This red point here is your vertex. Over 1, up 3. That's your vertex. This point here is our y-intercept. Those are the important points to this graph. And then we found some additional points. We reflected it to get that point, and then we evaluated the function.